Hi, I'm Mr. V. Today's our fifth day of dealing with similarity and similar triangles and similarity. And we're going to be talking about the Angle Bisector Theorem. This is found in the Desmos activity, where the objective is going to be to solve proportion and use proportions to solve an angle bisector, to solve problems with dealing with angle bisectors. To start this, I'm going to go through some of the homework, a couple of the homework questions. Which of the statements is true? The only one that's true is the angle-angle. Angle-angle triangle similarity theorem is valid, and this means that if you know two angles of one triangle, you can know that the two triangles are similar. So if I have two right angles and two angles like this angle and this angle. The other shortcuts that we have learned are the side-angle-side triangle similarity theorem and the side-side triangle similarity theorem. Now, what's true about the angles is that if you know the angles are congruent, then the two triangles are similar, and it only takes two of them because the third triangle would also be congruent if two angles are. What about the sides? What can you say about the sides? The sides are not congruent. This would not be the same as this, but they must be proportional. So if I had a 3, 4, 5 right triangle here, and I had a 6, 8, 10 right triangle, there would be a scale factor that you could go from one to the other, and here in this case it would be equal to 2. So if you have 3 as our starting triangle and 6 is the one we're going to, we could have a proportion. 6 is to 3, is 8 is to 4, is 10 is to 5. And our scale factor here is going to be equal to 2. That's what you would multiply the first triangle by, the starting one, which is the lower one here in the denominator, to get to the upper one. In a triangle ABC, it is taken to triangle A prime, B prime, C prime by dilation. Select all of the scale factors for which the dilation would result in an image that is smaller than the figure. And that would be this one and this one. We know that if we have a point of dilation, and I could draw lines from this point, and I'm going to take the triangle along these lines. So if I have this going to here, if I were going, and if this is my k is equal to 1, so this is my starting value. If I had another triangle like this, it would be congruent. If I had a triangle that was smaller than this, that would mean my k value would have to be between 0 and 1. If the k value is equal to 0, you're not doing a dilation. You have the point of dilation. And if I were going to a scale factor larger than 1, so if k is greater than 1, then I'm going to be getting larger. In today's activity, the first thing we had was a warm-up, and I'm going to do this on my whiteboard. I'll draw two figures. One is the smaller version, A, B, C, D, and a larger version of that same rectangle, A prime, B prime, C prime, D prime. Now, when we talk about similarity, you can go from the small triangle to the large, small triangle to the large, and that's what we're doing here. We're going from AD is to AD prime, as BC is to BC prime. So this is valid. You can also go within a triangle. So you could say, for instance, AB is to CD, as AB prime is to CD prime. This would be valid, and that would be D. So this first one, A prime is B, A prime B prime is to AB, as A prime C prime, which is a diagonal, is to AC. This would be valid. Here, we're going around in a circle. We're saying the small is to the large as the large is to the small, and that does not work. This one is even worse because I'm saying BC is to A prime D prime, as B prime C prime is to AD. So I'm not just going in a circle, I'm mixing up the large and the small. So this would be incorrect. I'm going to explain to you the angle bisector theorem. You can also watch this video, which will demonstrate it, and then I'm going to work through an example problem. So if I have a triangle, and let me draw this more exaggerated. If I have a triangle like this, and one of these angles is an angle bisector. So this angle is an angle bisector. Now I can draw a line that is parallel to one of the sides. Why do we draw parallel? We draw parallel because we can find all kind of congruent angles with parallel. Here we're given that these two angles are the same. This is an angle bisector. And I'm going to extend this angle bisector down to this side. Notice we have parallel lines. These two lines are parallel, and alternate interior angles. And if you don't see that, I'm going to draw them over here. The transversal crosses parallel lines to form congruent alternate interior angles. What else do we know? We know that these are vertical angles in the middle, so they are congruent. And if we call the sides of this triangle A, B, and C, we call the sides of this triangle D and E. I'm going to call this side K. Now, I know I have two similar triangles because I have angle, angle. By the angle triangle similarity theorem, these two triangles are similar. And I could redraw this and configure it to be like this one. I will do that, match them up so that I can make a proportion that is proper. Here we have side between the two ticks is B. The far side is A. And between this one is C. Now I notice that A is to C. A is to C as K is to D. Well, what I'd like to show with the angle bisector theorem is that A is to C as E is to D. A is to C as E. So this will divide this into a proportion. It does not divide the triangles into congruent or similar triangles, but it does divide it into a proportion. And here I've got this already shown that this is A is to C as K is to D. If I can show that K is the same as E, then I will have proved my triangle, my angle bisector theorem. Well, look, this large triangle here is isosceles. I have two angles that are the base angles are the same, so this side has to be the same as this, which means this is K is equal to E. So I have A is to C as E is to D. And now we're going to show you a problem with this using this particular theorem. So I can set up a proportion. I'm going to say x is to 21 as 30 minus x is to 24. When we cross multiply here, you get 21 times 30 minus x is equal to 24 times x. And I can distribute this. 24x is equal to 630 minus 21x. And add 21x to both sides, so 45x is equal to 630. Divide both sides by 45. X is equal to 14. If this was what I was asking for, that would be the end of it. If I asked for this side, I would have to plug it in. So I could say this side is 16 and this side is 14. At this point, I gave everyone time to work through some simple problems, a little bit more complex problems. Let me do that now. I'm going to do that here in the video. So if you had questions, the question mark we'll call x. And we can write x is to 9 as 20 is to 15. This simplifies, so I could write x is to 9 as 4 is to 3. When you multiply both sides by 9, you get x is equal to 12. The next one, this is our x. Since the whole thing is 20 and this is 6, this would have to be 14. So I can write x is to 6 as 21 is to 14. Simplified, x is to 6 as 3 is to 2. Multiply both sides by 6, and I get x is equal to 9. This side is x. We'll call it x. And this side is going to be 15. So x is to 15 as 8 is to 6. If I multiply both sides by 15 here, then I get x is equal, these two cancel. X is equal to, let's see, the 6, this becomes 4 and this becomes 3. The 3 cancels with this becomes 5, and I get 20. The entire length is what we're looking for. If I call this missing side x, this would be x plus 3. Notice how if the whole side is x plus 3, this would be 3 and this would be x. So I have x is to 16 as 3 is to 12. That is, x is to 16 as 1 is to 4. So if I multiply both sides by 16, I get x is equal to 4. And x is not what I was looking for. I'm looking for x plus 3. So when I substitute 4 for x, I get is equal to 7. Here we have the same kind of thing going on. This is 4. So I can say 10 is to 4 as 2x minus 5 is equal to 2. If I multiply both sides by 2, I get 20 divided by 4, which is 5, is equal to 2x minus 5. Add 5 to both sides. 10 is equal to 2x, and divide both sides by 2. X is equal to 5. And this is another one of those little bit more challenging. I'm going to put this in parentheses because when I multiply proportions, I want to make sure that I can do this. I'll do this one with the cross product property. Is to 21 as 28 is to 49. Notice I don't cross over here. And I could do 4x plus 8 is to 28 as 21 is to 49. I'm just going to keep it simple like this. I can simplify this ratio. For x plus 4 is to, and I'll put it in parentheses, is to 21 as 7 goes into 28 4 times. 7 goes into 49 7 times. And now I'm going to cross multiply. 7. In fact, I'll just multiply both sides by 21 because I want to get the x by itself. So I'll just multiply both sides by 21. At any point you can cross multiply, but I would find myself dividing by 7 again if I did that. 7 goes into 21 3 times. So x plus 4 is equal to 12. X is equal to 8. At this point, we change gears and we start doing some word problems or some different kind of challenging problems. This one is a word problem that deals with the angle bisector. Some of these word problems will not. I'll do this on my whiteboard. It has a triangle ABC, and I'll just draw a triangle here, ABC. And I notice that CA and CB are 5. So this side is 5, and this side is 5. This is an isosceles triangle with a vertex at C, and I have A and B either side here, and this length is 4. Now I'm supposed to draw an angle bisector somewhere here. This cuts this angle into 2 congruent angles. And I'm looking for this side and this side. The entire length, remember, is 5. So if I call one of these sides x, so let me just move my pen. If I call this side x, this would be 5 minus x. So if the whole thing is 5, and this side as much as x, how much is left? Well, this would be 5 minus x. Maybe you can see it better with the segment addition. So I can set up a proportion. X is to 5 as 5 minus x is to 4. I'll cross multiply, and I'm going to use parentheses when I do this. To get 4x is equal to 5 times 5 minus x. I'll distribute. 4x is equal to 25 minus 5x. And I'll add 5x to both sides. 9x is equal to 25, and x is equal to 25/9. Is that correct? Yes, it is. It's just not a very nice number, but we're in high school now, so get over it. If this is x, I need to find out what 5 minus x is, and 5 minus 25/9. I need a common denominator of 9, so I'll multiply by 9 over 9. Multiplying it by 1 doesn't change the value, it just changes the way it looks. So I have 45/9 minus 25/9, and that's going to equal to 20/9 for my other side. So 20/9, 25/9. The next question. There were this many students at Burlington High School in 2013. The girl-to-boy ratio is 2:3. I'm going to show you two ways of doing this. If I let x equal to the number of girls, then that means that the number of boys would be 975 minus the girls is equal to the number of boys. So I could set up this proportion, 2:3, girls is to boys, as x is to 975 minus x. And when I cross multiply, I get 2 times 975 minus x. Notice I use parentheses when I do this, is equal to 3x. And 2 times 5 is 10, 14, 15, 19, 20, 18, 19. 1950 is equal to 5x. And when I divide both sides by 5, I get x is equal to 390. Now, another way of setting this up would be to change this to say the girl to total is equal to 2 to 5. So if I do the 2 to 5, 2 is to 5 as x, my number of girls, is to 975. Well, look at this. That's what I had here, 2, x would equal to 2 times 975 divided by 5. And that's what I have when I do this. I have 2 times 975 divided by 5. And so x is equal to 390 once again. For the girls to boys ratio, I could try to divide 9 up into two numbers to give me a 2 to 3 ratio. I'm just going to use the 3 to 5 ratio. 3 to 5 is equal to x over 15. And notice my scale factor here is times 3. So if I multiply this times 3, I'm going to get x is equal to x in this case, which is the boys. I should say x is the boys in this case. I get 9. This next problem is a little bit more challenging. It says that we have A, B, C, D, and E along a number line in that order. A is at one end and E is at the other. B is the midpoint of these two, so this would divide this into two equal parts. C is the midpoint of BE, so this does the two equal parts, and D is the midpoint of segment CE. So these two are the same, which means I could divide this into those same number of parts. I could divide this into a total of 8 parts. There are 8 parts total. And if we're told that DE, which is 1 part, is 2 units, we could ask how many is AD? AD is going to be 7 units. So this would be is x over 7 units. So this would be 14. If BC, notice BC is going to be 2 parts, is 5. This is parts. This is units. And we're asked what is AB. A is going to be 4 units, 4 parts. So how many units would that be? If I multiply here, this would be 10. Multiply both sides by 4. Different still. Segment AB, which is 4 parts. If this is 5 units, how much is BC? BC is going to be 2 parts. And when I cross multiply, I get x is equal to 5 halves, excuse me, or 2.5. And finally, this is no different. It's just a little bit harder, but it's no different. AE, which is 8 parts, is equal to 9 units. That means that 1 unit would be 9/8. So how many is 7 parts? That is from A to D. Well, when you multiply both sides by 7, you get x is equal to 63/8. Is that correct? Well, yeah. 9/8, 9/8, 9/8, 9/8. You do it 7 times. Anyway. Let's see, where are we? There's a couple of other problems here. I'm going to leave them to you to solve. And if you have any questions, you can bring them to the class. So good luck and success.